Spent too much time in California. Now I got that Rona. Gotta be a loner. Staring at my phone. Gotta be a loner.
Gotta be a loner.
Hello, this is Judy again. It is... Now, what is the date? I actually have no idea. Should I find out? I think it's the 18th. How do you find out? Oh, it's March 22nd. Sunday, March 22nd. We've been in quarantine for like a week and a half. Something like that. Frank's looking at me funny. He doesn't know what the date is either, does he? Nope, just a dog. He's pretty happy about quarantine, actually. People around all the time. Sick life, right, Frank? He moved his head a little bit. Cool. All right, so I'd like to get in the weeds a little bit here. And I'm clicking around. You can hear my mouse. I'm clicking. So to build off something that I mentioned in the vitamin C episode, or maybe, sorry. To build off something I said in the first episode that was really about everything and nothing, was that, a lot of people in Italy are dying, and it was sort of difficult to identify what characteristics were leading to their specific outcomes, which seem to be so much worse than most other countries. And I'm reading that, at least as far as up to March 17th, 76% of the population that died had hypertension or high blood pressure. And then it also says 33% had heart disease. And if you've been following this story even a little bit, you've probably heard people talk about Ace-2. Ace-2 is angiotensin converting enzyme 2. There's also Ace, I guess, or Ace-1. I think it's just Ace. Angiotensin converting enzyme. And these are, I don't want to get too far into what they do because it's not that important, but so these are proteins that are that function in part of what is called the renin-angiotensin-aldosterone system, which regulate your blood pressure as well as your water balance and your sodium balance and electrolytes. And it starts in the kidneys, and basically it reads the concentration of electrolytes, especially sodium, in your blood as your blood filters through the kidneys, and it sets this pathway off to increase blood pressure. In many people, this system is overactive, and they have chronically high blood pressure. So, usually a first line of medication when people are treated for hypertension or high blood pressure are medications called Ace inhibitors or Ace-2 inhibitors, and basically they function to regulate this system, so that this system is, like I said, to increase blood pressure, and so it inhibits angiotensin converting enzyme or angiotensin converting enzyme 2, Ace or Ace-2. It inhibits one of these two enzymes in this pathway to not increase blood pressure and effectively lower blood pressure. So a lot of people with high blood pressure will be on Ace inhibitors or Ace-2 inhibitors. Like lisinopril is usually a first medication for people that are being treated for the first time with hypertension. And then further down the road, as your blood vessels become less compliant, a lot of times they'll get a higher dose, or you'll be in a combination of lisinopril and something else, a beta blocker or a diuretic or whatever. But this is a first line of defense, and they work pretty well. The thing is, what can happen is sort of a negative feedback, which happens often in human biology, is when you're inhibiting something physically. So these Ace-2 enzymes, they're actually in the lining of organs of your body, especially your lungs, your heart, your blood vessels. So when you take these Ace inhibitor type drugs, they physically block the ability for these receptors to function. So basically, picture them as like a hand coming out of the lining of a cell. They have a specific substrate that they bind to. However, you take this receptor, it comes in it sits in that hand and it blocks it. So that's great. But usually what's going to happen in a situation like this is your body is going to produce more of these receptors so that it can sort of compensate. So people that are taking these drugs tend to have more Ace-2 receptors, at least as far as I can tell from my research. Okay, so how does this play into the coronavirus stuff? Which is why we're here, right? So it has been identified that the actual target receptor for the SARS-CoV-2, the coronavirus, actual virus particle, binds to these ACE2 receptors. That's how it gets into the, like I said, these receptors are on the linings of the lungs. This is their target. Also on the lining of the heart, and there's evidence to show that the virus itself can actually have an effect, a direct effect on the heart, which is why people with underlying heart conditions are also having a lot of trouble dealing with and clearing this virus and having worse outcomes. So it has been proposed, and again, there hasn't been enough time during this outbreak to do, certainly not randomized controlled trials or even really much research at all as people are dealing with this crisis in real time. But we do know that this is the target for the virus itself. So it would be logical to assume that people with more of this target receptor are going to allow more virus into the body. However, some officials have stated that this is not necessarily the case, and people who aren't taking antihypertension drugs or ACE inhibitors who have, probably a normal amount of ACE2 receptors are still just as susceptible. This is what I've read. This is what I said. However, it is definitely true, at least up until this point, that people with hypertension and heart issues are having much worse outcomes. So there's definitely something going on. It may be the heart thing. It may be just this. So experts do believe that ACE inhibitors increase the binding target of this virus infection, the COVID-19 infection. So the question becomes, should people on these drugs should be extra worried, extra careful? And from what we've seen so far, there's no evidence to show that directly that ACE inhibitors increase mortality, okay? It's not the drugs, it's just this overactive system. Also, hypertension is a reflection of demographics, because older people just have higher blood pressure because, as I alluded to earlier, your blood vessels get less compliant, less able to dilate and constrict, which is how blood pressure is controlled. It's one of the main mechanisms that blood pressure is controlled physiologically. So as your blood vessels constrict, blood pressure increases. And the ability to do this constriction, or the dilation, which is the opposite, decreases over time. So older people have higher blood pressure. So maybe, again, we're back to older people have worse outcomes. Yes and no. But the main takeaway here is that ACE is your binding target. ACE inhibitors aren't necessarily, from what we've seen, the actual factor. So if you're on these drugs, you already have the overactive renin, angiotensin, aldosterone system, which means you probably have an increased ACE2 expression on these cells anyway. So you're already at a higher risk. That's just the way it is for this particular disease. Nothing I've read says stop taking your drugs. So definitely continue down that road. Keep trying to stay healthy. Lifestyle, diet, sodium, exercise, all these things can also affect blood pressure. So do all these things. Try to be as healthy as possible. Wash your hands. Quarantine. We know this stuff. I just want to talk about Ace-2. Mainly what I'm trying to get to is, you've probably seen that the French Minister of Health, I think is what he was, he tweeted that people should not take NSAIDs, non-steroidal anti-inflammatory drugs like ibuprofen, He himself saw that patients on these drugs were having worse outcomes, though this was not done scientifically. It's just what he saw, and was not basing his claim on any actual scientific evidence. And so it is definitely a possibility that, from what I've read, it seems that ibuprofen can increase the number of ACE2 receptors on a cell, which could make someone more vulnerable to infection. But again, and this might go slightly against what I just said before, but there's a virologist that was featured on NPR that said, just because you have more ACE2 receptors doesn't mean you're more susceptible to infection. Again, she says you can have low levels of ACE2 and still be susceptible. And goes on to say this is why we have clinical trials, right? So like I said, there has not been enough time to really understand what's going on here. But maybe despite the fact that there is no actual scientific evidence that would suggest ibuprofen is bad for you in this context, maybe take Tylenol. I mean, people use these drugs to lower fevers. Fever is one of the main symptoms of this disease. However, Tylenol does come along with more side effects, but if you're worried about COVID-19, that takes priority, and I think you'll be okay for now. Again, let's remember that a fever is your body's response to an infection, and it does serve a purpose. A lot of people want to get rid of their fever immediately. It is uncomfortable. It sucks, but it's your body's response. It's trying to kill off an invader. So only take a Tylenol or whatever it is you're going to take if you really need it. But I'm going to reinforce at this time that there is no scientific evidence, despite what the French Minister of Health says, that NSAIDs, ibuprofen, can lead to worse outcomes of COVID-19. Man, I just woke up first thing in the morning and I feel like I really struggled through this science. I can't even think right now, and I don't know why I tried to do this now. But I did. Let me know what I did. Let me know what I missed, okay? There's probably more out there, and like I said, there hasn't been a lot of time. So, more to come. But this ACE-2 stuff is interesting. I did not know about it until very recently. I mean, I knew about ACE-2, but I did not know about it in the context of this disease. So it's super interesting. If you have any insights, any research, any jokes, find me on Instagram, Alonavirus. Wait, no, the Alonavirus. Okay. Yikes.
Spent too much time in California. Now I'm in Pennsylvania.
Pennsylvania.